Hello. Hello students. Today we are going to study one of the most important topic in physics from which every year one question used to come in Neet JEE board everywhere, okay? That is wave optics Young double slit experiment that verifies the wave nature of light, okay? So let's start Young's double slit experiment. Dear student, let's see the experimental setup. This experiment verifies the wave nature of light. First of all, I am telling you some important definitions. What is fringe width? Distance between any two consecutive bright fringe or distance between any two consecutive dark fringe is known as fringe width. In the experiment of interference of light, fringe width remains same for bright fringe as well as for dark fringe. Okay, that we will see here. So what is fringe width here? Distance between any two consecutive bright fringe or between any two consecutive dark fringe is fringe width. Now let's see the experimental setup. In YDSE experiment, the main source of light is monochromatic source and S1 S2 are coherent sources which are obtained by division of wavefront method. And this is the screen which is located at distance d, which is quite large in comparison to separation between coherent sources. This is main coherent source. This is monochromatic source of light. Okay. Initial part difference in the experiment was 0. SS2 minus SS1 is 0. Okay. Now, dear student, let us see this is the center point. Okay. Now we are assuming let 8 point P. Let 8 point P on the screen, nth order bright fringe is getting from one question definitely come in whole exam. Okay. We will see each and every point in this YDSE experiment that will clear your fundamentals from 0 to hero. Okay. Dear student, first we are calculating for bright fringe. Okay. Let us assume 8 point P on the screen, nth order bright fringe is getting formed. And what is Xn? The light waves are reaching from S1 S2 to point P. Initial part difference was 0. There is no optical part difference. So dear student, let us learn the terminology, okay? Let xn and xn plus 1 equal to position of nth order and n plus 1th order bright fringe from central fringe, okay? In numerical problem, it is not necessary that the location of central fringe remains at the location of center of the screen, okay? It is not necessary. But here we have assumed, okay, for convenience. Position of nth order and n plus 1th order bright fringe from central fringe. Dear student, central fringe is called reference frame. This is zero order fringe, okay? This is always bright because here part difference is zero. Since xn is the position of nth order bright fringe, only geometrical part difference is involved here. That is xn d upon d. And this will be equal to n lambda because for central bright it is zero part difference. For first bright part difference is lambda. For second bright part difference is 2 lambda. For nth bright, dear student, part difference is n lambda, okay? So this equation is also very important. This xn. Xn is what? But dear student, this is the position of nth order bright fringe. Xn is what? This is the position of nth order bright fringe from central fringe, okay? So if this is the position of nth order bright fringe, then definitely we can write for xn plus 1. Substitute n plus 1 in place of n. This is xn plus 1. And what is fringe width? Distance between any two consecutive bright fringes. Distance between any two consecutive bright fringes is called fringe width, okay? So here xn plus 1 minus xn, that is fringe width, okay? This is what? See here, this is n plus 1 d lambda upon d. Minus n d lambda upon d. After solving this equation, we are getting fringe width for bright fringe is d lambda upon d. In this expression, we are observing here n is not coming. N means order of fringe. Means in YDAC experiment, all the bright fringes formed are of same width, okay? In YDAC experiment, all the bright fringes formed are of same width and fringe width equal to d lambda upon d, okay? Now let's talk about the dark fringe, okay? Now let us assume at point P, nth order dark fringe is getting formed. Initial part difference we have assumed 0. Waves are reaching from S1 and S2 at desired point P on the screen. SS2 minus SS1 we have assumed to be 0. Small d is the separation between coherent sources. Capital D is the distance between screen and plane of the slits, okay? That is S1, S2. Dear student, let's assume let xn dash and xn plus 1 dash equal to position of n plus 1th xn dash and xn plus 1 dash is position of nth and n plus 1th order dark fringe from central fringe. And we know dark fringe is formed at the screen when destructive interface takes place. Okay. For first dark fringe, part difference should be lambda by 2. For second dark fringe, part difference should be 3 lambda by 2. For nth dark fringe, part difference should be 2n minus 1 lambda by 2 when value of n starts from 1 to 3. So dear student, we can write here only geometrical part difference is existing. So we can write xn dash d upon d equal to 2n minus 1 lambda by 2. So equation, that is position of nth order dark fringe from central fringe. In numerical problem, this will be very useful. This is position of nth order dark fringe from central fringe. Okay. Now we can easily determine position of n plus 1th order dark fringe from central fringe. Okay. Substitute n plus 1 in place of n. This is position of n plus 1th order dark fringe from central fringe. Okay. Now, if we make the difference of xn plus 1 dash and xn dash, this will give us dark fringe width. Okay. Width of dark fringe. Let's say beta dash. We can write beta dash equal to xn plus 1 dash minus xn dash. This is equal to 2n plus 1 d lambda upon 2d minus 2n minus 1 d lambda upon 2d. After solving this equation, we will get d lambda upon d. So dear student, what we have observed here? In YDSC experiment, fringe width for dark and bright fringe remains same. Okay. That is all the fringes formed are of same width in YDSC experiment. Remember, this experiment verifies the wave nature of light. Okay. Now we will be looking at very important results on which numerical problems are based. Okay. Let's start one by one. Dear student, what we are observing here? This is first result, beta proportional d, proportional lambda, proportional 1 upon d, means on increasing the capital D, that the distance between screen and slit, the fringe width increases. The fringe width for red color light remains more than fringe width for blue color light. And on decreasing the separation between the slits, fringe width again increases. Okay. So this is the relation between beta and capital D, lambda and small d. Okay. Now look, effect of medium. This is very important relation. Beta medium equal to D, lambda medium upon D, and beta air equal to D, lambda air upon D. This is equation 1 and this is equation 2. Divide these two equations, we get beta medium equal to beta air upon mu medium, because lambda medium equal to lambda air upon mu medium. since lambda medium equal to lambda air upon mu medium. Dear student, since mu medium is greater than 1, therefore beta medium is less than beta air. So what we are observing? In the presence of medium, fringe width decreases. Fringe width decreases means number of fringes formed will increase. Okay. If the YDAC experiment is conducted in water, okay, water is having refractive index 4/3. So fringe width will become 3/4, means 75% of the fringe width of air. Okay. Dear student, beta water equal to 3/4 beta air. So if YDAC experiment is conducted in water, fringe width becomes 75%. Okay, that is fringe width decreases by 25%. Okay. If you calculate number of fringes in certain distance, n1 beta 1 equal to n2 beta 2, definitely number of fringes will get increased because fringe width is getting decreased. Okay. Now, dear student, let's see angular fringe width. Okay. This is the fringe distribution at the screen. This is central fringe. This is first dark. This is first dark fringe. This is first bright and this is first bright. This is second dark. This is second dark. This is second bright and this is again second bright. Okay. Distance between central fringe and first dark is beta by 2. Distance between central fringe and first bright is beta. Distance between first dark and first dark is beta. Distance between first bright and first bright is 2 beta. Dear student, if this is screen, this is S1 and S2. This is central fringe, this is first dark, and this is also first dark. This is beta. Angle subtended corresponding to beta. Angle subtended corresponding to beta is theta. Okay. Dear student, angle subtended corresponding to beta is theta. This is small d and this is what? Capital D. This is what? So when angle is small, what we will be writing? Theta equal to beta upon d, that is equal to lambda upon d. The same relation will come in medium, that is theta medium equal to theta air upon mu medium. Okay. This theta is angular fringe width. This theta is angular fringe width. Okay. This is angular fringe width. Dear student, remember fringe width and fringe position are different term. Fringe width and fringe position are different term. Okay. How? Let's see here. This is the screen. This is central fringe. This is first dark. This is first bright. This is second dark. This is second bright. This is third dark. Now let's see. All distances will be measured with respect to central fringe. The position of first bright from central fringe is beta. Position of second bright with respect to central fringe is 2 beta. Okay. The position of third dark with respect to central fringe is 5 beta by 2. Okay, so remember, fringe width and fringe position are different term. Okay, and the similar is the case for the angular fringe width and angular fringe position. Angular fringe width and angular fringe position. Okay, the similar is the case. Now see here. Suppose in numerical problem, if this is given, since central fringe and second arc means beta by 2, beta by 2, beta by 2. This is 3 by 3 beta by 2 means this will be equal to 3 theta by 2. Okay. Suppose whatever is the angle, so this angle is 3 theta by 2 is known. So we can calculate theta, and this theta will be what? This will be angular fringe width. Okay. So understood, angular fringe position. This is angular fringe position. This is angular fringe position of second arc fringe with respect to central fringe. Okay. This is angular fringe position of the second arc fringe with respect to central fringe. Remember, angular fringe position and angular fringe width are different term. Okay. Now, dear student, I am telling you very, very important thing now. What happens? What happens when a transparent slab is introduced in front of any one slit? What happens when a transparent slab is introduced in front of any one slit? The complete interference pattern will get shifted towards that slit in front of which a transparent slab is introduced. Okay. What happens when a transparent slab is introduced in front of any one slit? Dear student, this is very important thing. Okay. The complete fringe pattern will get shifted towards that slit in front of which the transparent slab was introduced. But remember, fringe width will not change. Fringe width will not change. Only fringe pattern will get shifted. Okay. So, dear student, how much shift will be there? That I am telling you. Suppose this is location of central fringe, and we have introduced a transparent slab of thickness T having refractive index mu. Now earlier what was the case? For central fringe, waves were reaching like this. Now because of keeping of this slab, what happens? This light wave is moving from rarer medium to denser medium. This will shift towards normal. Now again this will go like this. So this complete fringe pattern will get shifted towards that slit in front of which the slab was introduced. Let us assume this is X. So optical path difference created, optical path difference introduced due to presence of this slab is how much? This is mu minus 1 into T. This we have discussed earlier. And geometrical path difference came into picture because of this is XD upon D, where D is separation between coherent sources and capital D is distance between slit and screen. Okay. So from here we can calculate X. X is how much? Mu minus 1 T D upon D. And since beta equal to D lambda upon D, so we can write X equal to mu minus 1 T beta upon lambda. So dear student, this much shift will be there. So you can understand, if X equal to beta by 2, if X equal to beta by 2 means what will happen? In place of central fringe, first dark fringe will come into picture. If X equal to beta, then what will happen? In place of central fringe, the first bright will come into picture. Okay, dear student, hope you understood what will happen, the effect of the placing the slab. The complete complete fringe pattern will get shifted, okay, towards that slit in front of which the slab was introduced. Okay, understood? Now let us see. If we place the slab on in front of both the slits, okay, then what will happen? Now see here. Suppose we have placed one slab here and we have inserted another slab here. Dear student, let us assume thickness is T1, thickness is T2. Refractive index is mu1, refractive index is mu2. Because of this, the fringe pattern will go up by distance x1. Because of this, the fringe pattern will go down by distance x2. Okay. What is x1 x2? Mu1 minus 1 into T1 equal to x1 d upon d. So x1 is how much? Mu1 minus 1 T1 d upon d. And in a very similar way, x2 is what? Mu2 minus 1 T2 d upon d. So dear student, if x1 minus x2 greater than 0, the fringe pattern will shift upside, okay? If x1 minus x2 less than 0, fringe pattern will shift downside. If x1 minus x2 equal to 0, neither fringe width will change nor fringe pattern will shift in this situation, okay? So what is the condition when fringe pattern will not shift? This is mu1 minus 1 into T1 equal to mu2 minus 1 into T2, okay? This is the condition in which fringe pattern will also not shift, okay? Now, dear student, we will see condition for coincidence of bright fringes. Condition for coincidence of bright fringes, okay? Condition for coincidence of bright fringes. When YDSE experiment is exposed with the two color light having wavelength lambda 1 and lambda 2. Dear student, let us see, this is position of n1th order bright fringe of wavelength lambda 1 and this is the position of n2th order bright fringe of wavelength lambda 2. If the fringes are getting coincide, means xn1 equal to xn2. Means what? n1 lambda 1 equal to n2 lambda 2. If capital D and small d are same. From here, we can easily find the order of fringes, okay? Where the fringes will get coincide, okay? Hope you understood. In YDSE experiment, what happens when width of one slit is decreased? Remember, dear student, intensity is directly proportional to slit width. If width of any one slit is decreased, then what will happen? The bright fringe will become less bright and dark fringe will become less dark. Means what? Quality of interference pattern will get decreased, okay? And what is fringe visibility? This is given by I maximum minus I minimum divided by I maximum plus I minimum. Also remember, in YDSE experiment, if any one slit is blocked, that is obstructed by black color paper, then what will happen? At the screen now interference will not take place because for interference two current sources are required. When one source is blocked, then there will be uniform illumination at the screen. There will be uniform illumination at the screen, okay? And also remember, in YDSE experiment, first diffraction takes place at the slit and then interference takes place at the screen, okay? And interference fringes are hyperbolic in shape. Interference fringes are hyperbolic in shape. So dear student, hope you come to know many things about the YDSE experiment. You can easily solve the problem. In the next lecture, we will solve the related problems. Okay? Thank you.